This is our second example from Unit 4, Lesson 4. During a chemical reaction, the mass of a substance produced in milligrams can be represented by the following equation, where X represents minutes. So what I want to do right now is I want to be able to distinguish between the inputs and the outputs. So we often think of X and Y as our input values and our output values. In this problem, time represents the input, and time is in terms of minutes. The output is talking about the substance produced. So this is going to be our substance produced. And in terms of the units, it's going to be in terms of milligrams. So that's the first thing we want to do, is really understand this. What's going in is time. What's going out is going to be the production of the substance. Okay, so with that, we're going to plug this into the calculator. You're going to do this with me. And then we're going to use the skills we learned from Unit 1 in order to figure out how can we precisely figure it out what substance is produced at a given moment in time. So with me, please do a second plus 712 until it says RAM is cleared. All right, so to plug this in, this is a cube root. Can you shut the lights for me, please? This is a cube root. Let's see if that's a little better. And so we're going to go up to y equals, and how do we find the cube root? Please go on the left side and find math on the left. Then go all the way down to the fourth option. Inside is going to be x, subtract 2. Now notice the 1 is not underneath the radical, so I'm going to use the arrow to go to the right of it and go plus 1. I'm also going to go to the windows. It's already set the domain to run from 0 to 6, so 0 to 6 minutes, and then I'm going to do zoom fit, which is zoom 0. All right, let's get started. We're going to use this function to determine how many milligrams will be produced after 5 minutes. So let's figure out where's the 5 minutes. Remember, our input is in terms of minutes. So the first one I think is going to be pretty easy. We can go second, calculate value, and we're going to type in 5. And now let's round this to the nearest thousandths. So the nearest thousandths would make this 2.442 milligrams. Let's go on right now to part B. Part B, second, calculate. Okay, and value, and now we have 2. Now, a common mistake students make is I see students want to write 2.15. So the input is in terms of minutes. So we have 2 minutes, and then we have this partial minute. So we ask ourselves how many, and this should have been seconds, not sections. This should have been seconds. How many seconds are there in a minute? There are 60. So 2 full minutes, and then this partial. And again, if we round this to the nearest thousandths, we would have 1.62. Okay, it's 99. This is a great opportunity for us to talk about proper rounding. So I'm stopping here and looking behind. This makes it round up, which would be approximately 1.630 milligrams. The 29 rounds up to 30. Again, these are approximations. All right, with your partner, you have 5 seconds to do 90 seconds. Let's evaluate 90 seconds. Now, where do I see students often make mistakes? They're going to go second, calculate value. That's all wonderful, and they type in 90. Why is that wrong? Because this is in terms of the input is in terms of time in minutes. So you have a couple different ways. Some of you already know that 90 seconds is 1.5 minutes. Otherwise, what we're going to do is we're going to take that, I just did something wrong. We're going to take that 90 and we're going to go, how many seconds are in a minute? There are 60 seconds in 1 minute. And here's our answer. So we have approximately 0.206 milligrams. Now, before we jump into options D through G, I need to remind you of something. Let's go back to your Algebra 1-2 days, and maybe even Algebra 3-4. We expanded on this again. And let's say that we had a function. I'm just going to make this up right now. So we have the point right now is at 2, 1. So I'm going to write 2, 1. And then we're going to go up here, and we're at 4, 2. And we're at 6, 3. And I tell you that we have a function, and we're going to call this y sub 1. If you had to calculate what is the inverse of this, and I don't want, in particular, I don't want you to tell me what is the equation. I want you to tell me where would I find the inverse on this exact same Cartesian plane. There's a simple way of doing this. How many of you remember that when you find the inverse, you can take the x's and y's and flip them? Hands up high if you remember that fact. Okay, so here, 2 and 1 becomes 1, 2. So 1, 2. 4, 2 becomes 2, 4. And 6, 3 becomes 6, 3. And it's looking just like this. And by the way, that makes sense because as a reminder, if the two graphs directly reflect across the line y equals x, we can verify visually that they are inverses of one another. Why am I going over that? Because the x's and y's from one to the next are going to flip. So let's now come back over here. We have the exact same word problem and it says now use the function to determine how many milligrams will be produced after. So the first thing that they want us to do is to identify what is going to be the inverse of this. So you were just watching. So I'm going to start with the original function. And I'm going to write it as y equals the cube root of x minus 2 plus 1. Okay, another way to write cube root that you learned in Algebra 3-4 is this is called the radical form. The rational exponent form that's equivalent to this looks just like this. So whatever the nth root is out front here, it becomes 1 over that number. If this is a 5, it'd be 1/5. If this is a 2, it'd be 1/2. These are equivalent. I think it's easiest for us to start in this form, and now to calculate the inverse, I switch the x and y, and my goal will be to isolate the y. So what I'm doing is I'm doing PEMDAS backwards. That's what I'm doing. So I'm starting in this problem, and I'm going, okay, if I want to get y by itself, I need to add or subtract outside the parentheses. Got it. So x minus 1 equals y minus 2 raised to the 1/3. Done. Now, is there any multiplying or dividing outside the parentheses? There's not. Is there any exponents? Yes. How do I remove the 1/3? Well, we need to raise it to its reciprocal. Reciprocal means we take this and we flip it. So it was 1/3. I didn't flip it. Now it becomes 3 over 1. Why do we do that? Because when you multiply 1 times 3 is 3, 3 times 1 is 3, well 3 divided by 3 is 1. That's why. Or think of them right here. You guys often use the word canceling out. Really they reduce down to 1. That's why we do that. Over here I have x subtract 1 cubed, or 3 over 1. And my last step to isolate the y would be to add 2 to the opposite side. So this is the equation that I now have, and I do want to represent it in the correct form. So we have, this is the inverse. Now let's make sense of that. So that's my part 1, find the inverse. Now what is the output of this and what is input? Okay, so here's what I think of. The original problem, and we have the inverse problem. And let's not make this more complicated than it has to be. In the original problem, we had our inputs, like our x's, and our outputs, which we often want to say y's, but it's m of x here. Our input was time, it was in terms of minutes, and our output was substance produced, and it was in terms of milligrams. Now, when you find the inverse of with this function, we're just going to flip the concepts. So time is now not the input, it is the output. So time will be the output in terms of minutes, and vice versa. Your substance produced in terms of milligrams will be the input. So what is the output? Output is like our y's. For the inverse would be time in terms of minutes. What is our input for the inverse? It will be substance produced in terms of milligrams. How many minutes would it take to produce 1.5? So it doesn't matter which equation we use. We just know that we want to know when do we have 1.5. So I'm going to come up here, and I have the original equation, not the inverse right here. This is the original equation. So in my original equation, substance produced is my y. So I want to know when is the y equal to 1.5 million. So I come up here, I make the y 1.5. and I graph it to find that intersection. How do I know exactly where it intersects? To precisely find it, I go down to intersect and enter, enter, enter. Okay, so 2.125. This is the time, and this is in terms of minutes. Now they want us to be a little more precise. They don't want us to write down this exact. They want us to be a little more precise. And this is our last question of this example. I'm going to press pause, and I want the students in here to put this in terms of minutes and in time. So I'll tell you, yes, there's 2 minutes. But how many seconds are there? I see good talking here. So I know there is a whole 2 minutes, but then we have this remainder. So I take the remainder and ask myself, how many seconds are in there a minute? There is 60. So here we have 7.5 seconds. Or maybe you take the remainder, again, you could take it times 60 again if we want to go into even smaller portions of a second. I'd be completely comfortable with this. Completely comfortable.